The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of Hawaii Tracker and H. Very, the Hawaiian Volcano Education and Resilience Institute, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, August 24th, 2023. Kilauea, we thought, might be erupting by now, given the activity in the last couple of days. A lot of extra earthquakes coming up. That's what we'll talk about mostly today, is all the new earthquakes, and look into that in a little bit more depth. Volcano is still swelling, and on the surface, still quiet, as you can see here in our inset screen. How are you doing today, Dane?
Doing good. Looking pretty close there. You know, the summit had a nice little pump fake yesterday, and now we're kind of waiting again. It feels like, a little earlier this year.
Yeah, it really does. It's the third time this year we're going through the song and dance of the earthquakes ramping up and then potentially eruption popping out. That's how it's been the most recent times. It hasn't really led to any major intrusions, but in a couple other cases in the past, back in November 2020 and in August 2021, there were earthquake swarms of similar character that we'll look at, that USGS has mentioned as well. Compare and contrast those a little bit as we go through it here today. So yeah, quiet on the surface. Is there anything else you want to get in here, Dane, before we get going?
No, I mean, I'll just add in that if you got any questions about the Hawaiian volcanoes, go ahead and throw them in the chat, and we'll try and get to them at the end. We also have a little bit of announcement today, so stick around for that.
All right. So, and one other just note here to top, there have been some issues around here with the internet today. So we will hope that we stay steady with you guys, but some things may be out of our control. And another note, apologies to the mayor. We saw that he's got a live stream going on concurrently. Unfortunately, we did not hear about that till too late. So we were just going to hope that whoever needs to watch both can watch one of them recorded. So apologies for that. And here we go with our Hawaiian Volcano Tracker update this week. So let's get us started off here by changing our view. Put that on the screen there. And get ready for our Hawaiian Volcano Summary. So the Hawaiian Volcano Summary this week, you can see on screen a quiet surface of Kilauea, plenty of steam and a little bit of volcanic gas coming up from a rainy caldera there. However, this story is much different underground than on the surface. Underground, there have been lots and lots of earthquakes. So you guys can see here is the last week of activity, starting with the tilt here on top. So volcano is definitely still swelling, sometimes a little bit more, sometimes a little bit less, but overall stretching quite a bit to accommodate the influx of magma into the underground areas of its magma reservoir. And you can see that over the last 1 week here, we've had a spike in earthquakes, especially yesterday. We reached nearly 250 earthquakes just yesterday alone in the entire Kilauea area, not just the summit here. See, it's come down a little bit today. We're not done counting for today yet, but that really was the highlight, and it seemed like it might actually lead to an eruption yesterday. However, it did not, and this is usually what happens about half the time. It seems like it doesn't always lead all the way to an eruption. It can inject itself underground and make more space, and if a volcano can stretch enough, quickly enough, then it won't actually ever come to the surface, but it'll keep pushing and pressurizing and causing that dynamic system to keep adapting there. So up on top is just earthquake counts right here, but we have in our 1 week plot as well a depth versus time option here. So the only reason I want to show this right here in our summary is to share that all these earthquakes are occurring here in the shallow regions. Since this is capturing all of the Kilauea area, we want to make sure that it's not a big pahala swarm down here at depth. So these are still happening at background levels, but most of the action is up here. You can see this really dense cloud of points here on the right compared to what you see just over here on the left. So all the earthquakes are shallow. There are lots of them. And if we look at the map here, we can see that really they're all concentrated around Kilauea summit, and especially this arm that goes to the southwest and the seismic southwest rift zone right there. Here's our Pahala earthquakes down here in a corner, south flank earthquakes as well. So our total numbers won't be as high as I mentioned for just the summit alone. But this is just validating that activity is the summit signal that we're seeing here. And that allows us to then compare that to what we've seen in the past. So here we are in our 1 month earthquakes per day over the last month. This is yesterday, almost at 250. And you can see that the day before that, it was down around perhaps 130 or so. So not quite double there, but a big jump for yesterday. And even that 130 was double than we saw a few days earlier in the week, where it was down in the range of 60 or so earthquakes in one day. Now that follows our update from last week. Last week, we were right around in here or so. So we had just seen this first earthquake flurry come up, and it actually started tailed off for 3 or 4 days there, and came back up to that peak right there. And so kind of cycling with more and less pressure. But now it's reaching levels that we have not seen yet over much of the previous month. And if we go back to the previous year, we can see that these levels of earthquakes per week now are getting to the point where they're similar to what we saw prior to the June eruption, 2023, prior to what we saw in a January eruption, which is back in here, and also prior to what we saw, January back in here, and also similar to what we saw back in the previous years. I got to scroll back to the 5-year earthquake counts now. Now we're looking at earthquakes per month. Here we are in the far right, potentially leading up to an eruption, and here is June of this year. Here is January of this year. We go back further in time. There was at the end of the eruption back in 2021, it was something in May. That was a little bit unusual there, but otherwise the next highest signals we see are in August 2021 prior to September eruption. And going back even further, it goes back to November 2020, just prior to the December eruption. The point being that this pattern of earthquake activity can last for more than a week. It could last potentially a couple months or so. But in every single instance within the last 5 years here has led to an eruption eventually, all at the summit. So that's the summary of the conditions on Kilauea right now. Earthquakes are quite high. We're waiting to see if this will draw out further. If it continues ramping up at this rate, it could lead to an eruption within only a few days. However, more likely is that it holds to this pattern and keeps pressurizing and relieving and pressurizing and relieving, and eventually does erupt sooner or later. So that's our Kilauea summary there. And I thought I would just summarize Mauna Loa with a map of the summit here. It's hard to see. There's not a whole lot on this map here, so I'll zoom it into the caldera region a little bit more here. And what you see is some small dots showing earthquakes on the southeast part of Mauna Loa. That's the normal background of this side of the mountain adjusting towards Kilauea. And the colors are depths of earthquakes on this particular map. So these blues and purples are just really showing this cluster, this cloud of deep earthquakes underneath Mauna Loa summit region that have been ongoing now for a little bit over a month. So they started off with a little bit more intensity. Now they're a little more sporadic. And that's the most interesting thing happening in Mauna Loa is those deep earthquakes. And the shallow level is not quite so much. The volcano is still swelling as magma comes into it, but that's expected in a long pattern following an eruption like we saw in the end of 2022. That's the Hawaiian Volcano Summary for the week. And we'll move on to share a special request for you guys today. We are actually trying to measure our impact on our community here. And this is in part for some of our grant reports that we're writing up. And so we'd like to share with you guys a survey. This is completely optional, of course. Thought I'd put it on the screen here just to show you guys how simple it actually is. We only have 10 questions plus one bonus. Where do you live is the bonus here, right? So, and then the questions are all just, can you rate from 1 to 10 these question pairs, for example, which are all measuring our impact. So if you guys want to look for the link in the comments there, and if you'd be so kind to fill us out for us, either now or later on, depending on what works better for you guys, we'd really appreciate that. So here's our first reminder. We'll remind you guys and drop it once again here at the end of our broadcast today. And with that said, we'll start off today with our Kilauea observations, actually. We don't have a whole lot, but we are going to turn to @Cosme64833127 on Twitter, who is showing us here data from Sentinel, showing the cooldown of the eruption within Hale Ma'u since its in mid-June there. So there is that area of the lava lake that was all active during the final stages of that eruption. And then cooling, you can see a few redder spots glowing across the caldera there. But this is our observations for really the last few months here, the last 3 months since this eruption ended. It's just pretty quiet on the surface, still hot, obviously. That's why it's still steaming and degassing. But overall, a lot less activity than we saw before. So that's our observations we can share today. And what we'll do next is go into our monitoring. Let's pull up the monitoring graphs here and add some context to the earthquakes a little bit, right? So here's our 1 month of earthquakes. We pointed out how this is the highest value in a month, even exceeding what we saw last week here. And on the same 1 month plot, you can see there's a couple bumps. There's a first bump, second bump. So I'm going to scroll this up here and put it on our tilt, and you can see similar increases in the rate of ground tilt around both of those times there. Notice that this little decrease that we saw corresponded to the decrease in earthquakes as well. So that's the cycle, that first pulse coming through and then slowing down, and a second pulse coming through, more so right in there. But the pattern being overall that it's within the last month still come up 20 microradians, which is quite a good amount. It's exceeding our average, I'll put it that way, for those of you guys who haven't followed for very long. And within the last week or so, you can see right through here, come up perhaps maybe 5 microradians, maybe a little bit more than that. So it's still moving pretty good there. This is the summit signal at Uekahuna, which is at the site of the former Jagger Museum up there. However, the Sand Hill tilt meter just off to the southwest is also showing this pattern, as we've been sharing with you guys for a few weeks here. And its component we're going to look at is this blue one here. So maybe -3 to +6 or so, not quite as big a range, but it is showing that pattern that's maybe a little bit more localized to this area, because that earthquake swarm is close to the Sand Hill station. And the Sand Hill tilt meter was mentioned in a USGS report a couple of days ago, so we'll cover that as well. But this is what they're talking about here, is this tilt meter actually still showing a pretty decent rate of inflation here, even if this one further up at Wikahuna is not showing quite as drastic a rate as it was last week. Right? So, but it's still consistently both inflating, maybe to different degrees, a little bit here, a little bit there, because the ground is bulging slightly differently in different areas. So that is the tilt around the summit. Down at the East Rift Zone, we have a tilt meter also by Pu'u'o Crater. And this blue line is what we're looking at. And it's showing the ground actually deflating, tilting back in towards the rift zone there. So that's showing the magma is not going through that area today. And the volcano is still kind of sagging. It is wiggling and moving around because the whole volcano is shuffling like a big bunch of blocks getting pushed out of the way. So it is wiggling and moving, but it is doing that while sagging at the same time. And that's what the tilt meter is showing us here on a East Rift Zone. There are a couple of bumps on here, which are sometimes things we get questions about. So just point them out. This is a little earthquake offset. When you see the line come up so straight like that, that usually is showing that the ground just got moved instantly from here to there and didn't actually come back. Sometimes you see like a spike, the ground moves and it comes back to normal. That usually is more likely if an earthquake is far away from the station. If it's really close by, it can actually move the ground and like actually leave it offset. And that's what we see here with this blue signal, is the earthquake actually moved the ground. And we know Pu'u'o is all sagging and collapsing, and so there could be something that just settled a little bit to cause that potentially there. But that's what those signals usually mean when they're straight like that. And further over here on the right, we see another signal that rises up, but this is not a straight up and down one. It actually comes up a little bit more slowly. If you are in the area, you would realize that this was corresponding to another big rain event that came through in this area of the Glenwood Forest near Pu'u'o here. So that is what you're seeing there. And otherwise, pretty steady deflation and nothing, no cause for concern in a rift zone, as shown by the tilt here. Other signals we have in our monitoring toolkit here. One is the lava depth. The lava depth went offline a little bit for a few days earlier this week, but has come back up just today here. So you can see the pattern is still that of a decreasing depth with this cyclic variation that we see every day that we believe is based on temperature here. For the last month, not a whole lot of information on SO2 that's really insightful, with no measurements in the last week. Our last one is still down at around 85 tons per day. And all these measurements in the last month are all in this very low range of 140 to 85 or so. So very low values. It's hard to really get much out of this. It just looks like a little bit of a scatter. To really show you guys the true scale, I'm going to zoom out to the whole year. Let's look at year-long plots now. And this year of SO2, here we are in the bottom right over here, pretty close to zero, considering that when these eruptions begin, they can shoot up to 10,000 tons per day, or in this case, 75,000 tons per day. So really being down here around 85 is pretty much nothing as far as the volcano is concerned. However, as we've noted before, these are low levels for the volcano, but if this was an industrial facility operated by humans, this would be something that EPA would fine, because even those low levels are quite impactful for people living nearby. If you're downwind, and especially if you're sensitive, asthmatic, or have any other respiratory issues, that can be really a cause for concern. And as a volcano prepares to potentially erupt, that's something to be aware of, that the gases get really bad when eruptions actually begin. The first day is the worst, the second day is the second worst, and then it gets a lot better in the days following that for the most part. So keep that in mind if this thing does build to an eruption before we get back to you guys and you are in the area and sensitive. Otherwise, the gas is looking pretty good here, and we'll show you guys the consequence of these low values blowing around here later on in our update. So 1 year of earthquakes, we've shown this one before as well. Here's our high earthquakes per week values. We're actually around 700 earthquakes per week, both of last week, and we're not quite done with this week according to the way this thing counts. So pretty high. We're actually at this level, higher than we saw in January, right, but lower than we saw in June. So it's interesting to note that, and this brings up a point that I've heard discussion about, not just on the earthquakes, but also like on the GPS and the tilt meter and all of that, is trying to compare the exact absolute values of the numbers like this to the ones over here and the ones over there. And, to me, it's just good enough to say that they're both elevated compared to the background. I don't need to know that this is actually absolutely compared to that, something that I can make a conclusion from, because the problem is this volcano is not elastic. By that, I mean like an elastic, something that actually stretches out, and when it's done, comes back to its original shape, and then you can kind of reset your measurement and start over and kind of compare measurement one against the other. But if the thing stretches out and then doesn't come back all the way together again, then you haven't come back to your baseline. And so you can't exactly compare what's happening now as far as earthquake numbers, as far as absolute value of tilt, as far as absolute value of GPS. All those things change because the volcano is stretched out with each eruption, and it doesn't go back to where it was before the eruption. So you can't, for example, look at the tilt meter or the GPS. Here's our GPS line for the last year, right? And say, okay, well, back here in January this year, when the volcano stretched this far, that's when it broke. Clearly, we have stretched it further than that here, and it still hasn't broken this most recent time here. It did a little bit in June, that was this, but at the very end here, not as much, right? So just to show you guys an example of how this thing doesn't always reset back to baseline. So, but looking at the GPS, there's our eruptions I just mentioned. There's the one that corresponds to the earthquake drop there, and the one in, well, that actually was not the June one. The June one was back in here. Or am I looking at this wrong? This is the June one. Yeah, this is a June one. My apologies. And this is a January one right over here. And this was just the last week little decrease in earthquakes that we saw. Let's see if I go back up to, since I messed it up, I'll explain a little better here. If we go back to this 1 month count of earthquakes, it kind of came up, went down, and came up again. This little lull in here, that corresponds to this lull in the tilt right in there. That also showed up in a GPS, but a GPS is a 1 year scale. So it compressed to just that little zone right in there. Right, so that was just last week. This is the June eruption, and this is the January eruption right there. And so January and June, so exceeding both those values as far as absolute stretching amounts. Okay, and for completeness, to reassure, because the reason we do all this, all our updates is to make sure that we are aware of what's happening at the volcano, how it affects people, especially in residential areas. And the residential areas that are occupied on Kilauea are mostly down on the lower East Rift. So we keep checking the lower East Rift. Tilt, here's our GPS once again. You can see the value is going down. That means the number is getting smaller. The sides of the rift zone are getting closer together as the thing once again continues sagging. So this is for the whole last year. Our tilt plot was only for the last month. So just showing how steady this pattern has actually been, including its little wiggle. Sometimes it actually will wiggle up, it will wiggle down, wiggle up, wiggle down. So those little variations are normal. We saw some of that happening right here at the end, but it seems like those are all still minor variations within this larger trend that's still a contracting, sagging trend here on the Middle East Rift Zone. So that is the 1 year GPS. What we're going to do is switch over to our 2 year GPS, not to look at it in huge details, but what we normally like to do with these is, because we have more stations, we can then look at different components. And what I'm really interested in today is the vertical components of the stations around the summit. So here are summit stations. This is our east-west component, our north-south component. This is the one we want, up and down component. So bottom of the 3 panels each time. So, and we're looking at Wikahuna in the northwest, Byron's Ledge is in the east, Crater Rim is kind of in the south, and Outlet is in the southwest area, more or less, to give you some orientation. It's kind of around the caldera area, a little bit as best we can with the precision of the instruments there. But what I really want to show you guys is, let's zoom in at Wikahuna right here. Might be as much as I can get it. Maybe, yeah. So then what we want to show you guys is this spot right here. So these are now 2 year plots, so it's compressed even further than the last plot. So now this is June, and now this is January, and we have a lot more going back before that, right? But the important thing is, look at how much vertical offset's happening here. And this thing, the highest point is right there. The next one down is right there, just in case you guys can't see that well. I'm trying to highlight them a little bit, right? Really notable vertical increases. It's starting to push upwards as much as it has pushing outwards. So that shows how it's getting pretty close to popping there, which volcanically could still be days, 2 weeks to months potentially, right? If it really starts and stops more often. So Byron's Ledge further to the east has that similar pattern, rising up as well, pretty steady right in there. Let me scroll down here to the Crater Rim station. That one also showing up and down. That one's showed like it went up and then came down actually since then. So some variation going on there. Maybe that's reflecting what we saw as well, with a decrease over the last week of earthquakes temporarily, the first few days of the week. And the last one over here, Outlet, also showing pretty dramatic upward motion right there. Right. So if I could, it's hard to really put full confidence in these values that come in here at the right end of the graph, because sometimes there's corrections and adjustments that are filters that are put through here. But with this preliminary raw data that we see here, it is showing this pretty high up. To my eye, I would say that this highest point here looks like this 0.12 or so. And I would say that less than a week ago, we were down here at 0.8 or so, right? So we're looking at maybe 5 centimeters, a couple inches the ground has actually lifted up at this spot in the last week. That's a huge amount for the ground to be lifting up. So that's just showing how active a volcano actually is. Remember, it can stretch and bulge quite a lot without actually erupting. So that's really the question there. Which is going to happen faster? Is it going to stretch out faster, or is it going to fill up faster? And then that determines whether it actually pops out the top or not. So those are our stations showing that vertical offset around the summit. If we go to the East Rift stations, like Mauna Ulu, we don't see that. Kananui Ohamo, we don't see that either. Going down, go here to Kamoamoa, don't see that, it's going down. We go to Pu'o'o, going down. It's just around the summit area, right? Until you go down to the south flank areas. The south flank areas near the summit, they're also showing it. So Ahua, also rising very fast. Puhimau, also rising very fast. Devil's Throat, also rising very fast. And that's about the edge of it right there. If I go further south to Ainaho, not so much. Makai Makopui, not so much. Kalapana Trail, not so much there. And that's really the end of it. There's no point in looking any further. So that's just showing you the range of where the ground is rising up. I'll point this out on a map here in a minute. But what I wanted to do next is go through a few of these updates the USGS has issued, because they're actually issuing them every day now and putting out a good amount of information in each one. So I'm not going to read everything. I'm just going to highlight the things that are different from one to the other. And we're going to skip to start on Sunday, August 20th, when the update came out there. At that point in time, they noted that over the past 4 days, the earthquakes at the summit of Kilauea had decreased relative to the past 3 weeks of increased activity. Similarly, the increases in inflation also stopped. And that's mostly the story of last Thursday through Sunday. No other activity elsewhere in the volcano. Then come Monday morning, they note that early in that morning, 1:30 to 5 a.m. Hawaiian time, a small earthquake swarm of approximately 20 earthquakes occurred at a depth of 1 to 2 miles below the surface, south of the Halemaumau crater. The swarm occurred in the same location as the swarm on August 16th, and is likely caused by movement of magma in Kilauea's South Caldera region. There's a process observed consistently at the summit. So that's the important thing there. They're noting these depths, 1 or 2 miles, magma movement being noted there. And we'll show you some evidence of that as well. But let's finish out a couple more of these updates. So Tuesday, they came out and say that yesterday evening, so also Monday night, 5 to 9 p.m., a small earthquake swarm of approximately 25 earthquakes occurred at a depth of 1 or 2 miles. This is a third earthquake swarm in an area in the past week, and likely caused by magma movement. And we'll keep going for now and come to Wednesday. Show you guys that Wednesday morning, 4:30 to 8:30 a.m., an earthquake swarm of approximately 50 earthquakes occurred at a depth of 1 or 2 miles. This is the fourth earthquake swarm in an area in the past week, and likely caused by movement of magma. So it just keeps going. And then today, no new swarm to really note, but I do note elevated swarm-like activity continues at the summit, concentrated in areas south of the summit caldera. Most earthquakes have been at a depth of 1 or 2 miles, 2 to 3 kilometers below the surface, with no upward migration. That's a key thing there, right? If it's moving upwards, that's what leads to an eruption, is actually pushing its way towards the surface, as opposed to filling some crack or other void that does not have a path to the surface, where it can keep injecting and pressurizing, filling space, but it's not actually cracking towards the surface there. And here they note in today's update, the recent trend of inflationary tilt continued through the past day with some variability. The earthquake activity and tilt meter data indicate that the summit is becoming increasingly pressurized. Right? So it is pressurized, and it's going to get more and more pressurized, and it's just a question of how much it can stretch to whether it erupt, as I've been repeating. They do note similar episodes of earthquake and ground formation activity occurred in November 2020 and August 2021, prior to eruptions in December 2020 and September 2021. Activity is currently confined within Kilauea summit region, and if it continues, could escalate to eruption in the coming days, weeks, or months. So I know the USGS likes to hedge their bets here, but the key thing to note is they're saying it could be as soon as days. That's how I read this. This could be as soon as days. Could be weeks and months, of course, but that's our standard. It always could be weeks or months. That's background normal all the time. And they're saying possibly could be within days if that pattern of ramping up continues, which it looks like it may not be given the earthquakes today, but you never know. The storm could be still coming as we speak. So to hedge their bets, they say activity could also decrease due to an intrusion of magma underground or other changes resulting in no eruption. So they're not sure what's going to happen. They're trying to lay out all the possibilities. It's about equally likely that there is no eruption within this shorter time frame, because we have seen, for example, in both those previous cases, it took another month for it to actually erupt. And there are situations like we saw on Kilauea. This was October 2022, I want to say, Dane, as Mauna Loa was ramping up. We saw, maybe it was November, we saw an intrusion below Kīlauea summit as it was still erupting. That was unusual, likely affected by Mauna Loa's pressure pushing on Kilauea there. But that was one of the few that intruded, and it did not lead to a change in eruption at the surface. It led to, as far as it actually erupting more, it led to the opposite. It led to erupting less in that case. Right. So that's just to show how it can go either way there. So, but we'll look at these comparisons with these other two time periods here as well, since that's the interesting thing to talk about for the rest of our time together here. So that is our monitoring, and let's look at the earthquakes a little more closely now. And we'll do that, if I can, by starting with the earthquake map here. So what I have selected is the last 7 days. These are now colored by time. So red is in the last, was the key here, last 2 hours, last 1 hour there. Orange is in the last day, yellow is in the last week, and I haven't plotted anything older than that. And so here they are. Here's the pattern. You can see this cluster that extends to the southwest from the caldera, from the main caldera. I like to zoom it in here just to show you guys. Here's our main caldera with the largest cliffs that you see, right? The most offset where it's collapsed the most right there. But I call that the main caldera because we also have what we call an outer caldera, a larger collapse structure that exists around Kilauea that goes more like this, more or less like that. Then it comes down through here and goes around there and kind of reconnects back up that way. So there's also what we call the Great Caldera as well. So these are south of the main caldera, but straddling the Great Caldera area right through here and shooting off into more of what this area would be, what we'd call the seismic southwest rift area further in that direction. I'll explain that here in a minute. But you can see that the most recent earthquake is down in here. 2.2 just happened, 0.1 miles above sea level, so pretty close to the surface there. And let's see here. Why are my earthquakes not listing on the map? Well, I'm not sure why they're not listing in here, but okay. Well, I could change some of these settings. What I can tell you guys is that over the last week from this cluster, we can change the settings to show only magnitude 2.5 and higher. And of those, we've had 8. So there are 8 earthquakes, magnitude 2.5 to 2.8 was actually the highest one. Let me see if I can put that on screen for you guys here and actually have it show it. So there is the 8 right there. So in that region, those are the largest ones. Everything else is quite a bit smaller. But with magma, that's how the story usually goes. It's not about how big the earthquake is. It's about how many and how frequently are they occurring. That's what really indicates to us that the magma is still filling an area underground. We'll put this back to, let's go back to the last, all magnitudes for the last 7 days here and show you this pattern, right? So not only do we have that tail to the southwest, there is quite a bit of dispersed activity around Hale Mauna crater right through here, a little bit over in Kilauea, some apparently along the south caldera edge over here on the south. And we know that when Kilauea is swelling and bulging outwards in every direction, it also catches in this point over by the campground on the Kanipayo against Mauna Loa. So Mauna Loa is trying to push this way. Kilauea now is pushing back. And here is that one of those pinch zones that seems to flare up when that's happening. Right. So would not be surprised to see more earthquakes over the next few days and weeks here as this thing pressurizes more and more and more to potentially erupt. So that's the pattern on Kilauea. I can zoom it out. You see a few earthquakes down on the south flank, but nothing unusual, all within a background there. A few in Mauna Loa's northeast or southeast flank over here. Similar adjustments ongoing for the eruption site, which is more or less in here from 2022. And still having Pahala earthquakes ongoing in the south, associated with a hotspot feeding all the volcanoes. So coming from very, very deep down and coming towards Kilauea, towards Mauna Loa, and towards the volcano formerly known as Loihi, Kamaehua, Kanaloa, over off in that direction to the southeast. So that's the big picture of the earthquakes there. There are some other scattered ones around the islands while I'm here. Background events over on the Kona side, on the Mauna Kea, on the north. These are all just these normal settling events, whether they're deep or shallow. That's usually what they are and part of the background. They can occur anywhere, and it's not volcanic. Nothing to worry about there. Like the whole island's having to adjust to all the action down here in the southeast. It's a little bit unbalanced. It's like a big seesaw. The bottom right part, they're trying to rise up and get filled up, and the other part trying to tilt down, and the whole thing having to adjust, and it's moving all the time. And so that's why you have earthquakes all around there, adding to the actual weight of the island on the seafloor, bulging downwards into the mantle. So there's a big picture of earthquakes. I thought I would do next is zoom way back in to the Uekahuna station. This is the seismograph from Uekahuna for the last 48 hours. So what you see is these little wiggles that start like this and get a little smaller, those little earthquakes. The really small ones just show like a little line, and that's it. So these would be what we call the micro earthquakes. These are the ones that may not even show up on a map at all, right? So the map is picking up events that are big enough to actually show an onset and a decrease afterwards. Maybe it's the best way to explain it to you guys. It's like that one probably shows up. That one might show up, right? But this one probably doesn't. And this one might not either. It's hard to tell, right? These little ones might not as well. So just an example of how much more micro earthquake activity is actually happening. This is how we look at it in the seismograph here. And on this kind of view, once in a while you see this kind of activity happening, this darker blue band right in here that lasts all across this plot, right? It actually starts here, wraps around to the next line, keeps going here. So this thing lasts maybe 10, close to 15 minutes. It's 15 minutes for one line left to right all the way across. It's 15 minutes. You can read top to bottom. So here's another one that comes through. This is a harmonic tremor signal right there. That's showing fluid movement through some crack underground. So at the same time as we're having these earthquakes, lots of small earthquakes all around here, we're seeing following and associated with that tremor showing magma actually moving, right? That's one of these signals. The thing is, it's not sustained. So it's kind of moving and then stopping, and then it moves a little bit more, and then it stops. And so pressure is migrating and it's moving that way, but it's not actually like pumping, injecting. It's like going nonstop, right? So when it gets to that point, we'll be closer to eruption. We might see tremor happening more often. So we're seeing it coming in now, and this does jive with what the USGS is saying there, likely due to continued magma movement in the South Caldera there.
Did we just lose Phil? You there, Phil?
I'm just going to pause for a second here. Looks like I'm frozen.
Yeah, I think Phil might be having those issues we were talking about at the beginning of the stream. Bear with us for a minute, and hopefully he is a robot right now, at least in my ear. Hopefully that will resolve itself here momentarily. We'll be able to get through this. But yeah, yesterday we were really thinking that it might go. We were talking at Pahoa School to the 8th grade science class and told them, like, hey, if we got to step out for a moment, you know what happened? Oh, I heard the robot come back. All right, just bear with us for a moment. Technical difficulties, part of living on an island and having a power pole transformer go out, it seems, near his place recently today. So we'll see if he can come back. Hopefully we get him back in there. We are looking at the earthquakes here. I do not have control over that, but yeah, we are now in the waiting phase, right? The wait to see if it ramps up or if it's more like the previous eruptions where we get multiple pump fakes, where it builds up. We think it's going to go. This one, it even gave us tremor. Phil, are you there? He's still kidnapped by the robots. Oh, he's muted. That's what it is. You there?
Hi guys, I think I'm here, but let me make sure my settings are still correct.
All right. I'm glad the robots didn't get you.
Yeah, somehow survived. I'm not sure what happened there, but I am back now. Thanks for filling in, Dane.
Yep.
So yeah, as Dane said, we're still waiting to see what's going to happen, if it's going to ramp up or not. But we're seeing all these signals of it actually picking up, including this tremor right here. Right. So this is just one signal from one seismograph. That if I were to zoom it out, that's that band right in here. So just kind of quickly, you can note that it's occurring at various other places. I could come down to the Sand Hill Station, for example, down in here, and note that it's also got these tremor bands coming through it. So without going comprehensively through everything, just note that it is happening there and move on from that, because I also want to show you guys a different view that this might be why I'm lagging. I'm not sure, but I wanted to share with you guys the spectrogram view here, right? So this is something that we're pulling off from the raw data from the stations using Swarm software here. And to explain, since I haven't shown this much before, what I have here is each of these bars across the top is a station. This is Uekahuna, Crater Rim up here, Sand Hill, Puhimau, Devil's Throat. These are the ones in that area that I showed you guys. The ground is rising pretty fast. So in these upper bands right in here, what you're looking for is these vertical lines. Right? What you're looking at essentially is top to bottom. This is a whole spectrum of the earthquake energy being released. And usually the big earthquakes create stripes all the way top to bottom. So when you see a big event with a red stripe like this, actually two of them right in there, that size earthquake will show up on a map. That was, I want to say, a 2.5 or 2.6, something like that. But some of these other little ones that look like little stripes do not show up. So this is a good way to look at micro earthquake activity when you see it mostly this light green color and not this background blue like down here. So this down here is Kananui Ohamo, Kupayanaha. This one kind of is down by Highway 130, which was installed in the 2018 eruption. So this one's near the highway. So sometimes you can have extra noise. The reason I like to keep this one in here is to show you, remind myself that what a human noise might actually look like. And so there it is right in there. You see not quite the same structure. Some of the earthquakes do come through in stripes all the way down across everywhere. So you can see those are some of the ones that are shaking the whole edifice of the volcano there. But otherwise, what you normally see is a lot of this kind of blue stuff, right? And you see a little bit on the bottom, the low frequency stuff, which might be the ocean waves and cars and things like that kind of create a more of the low rumbling energy through the ground there. So these are all the Southwest Rift down here, Cone Peak, Desert. So nothing is happening in the Southwest Rift. Nothing's happening in the Southeast Rift. It's all contained up here at the summit region, and micro earthquake activity is intense. Not only that, you can kind of see that there are some times where you see, okay, here's a good amount of activity happening right there. But now you examine it following these two earthquakes we just had within the last hour here. There is a lot of green in here and hardly any blue. Actually, there's more green in here than blue compared to areas like this where there's more blue than green. So quite a lot of micro earthquake activity picking up. We don't have the raw values that we can show you guys just like that. It is possible to plot the counts of when you have the most events, but hard to show you guys in that kind of format without going through a lot more explanation here. So we'll just leave that as that. I'll keep this running here in the background in case we need it again. And we'll move on to show you guys the cross-section of Kilauea volcano to try to place these earthquakes in 3D space for you guys. So the first thing to remember is that they said these earthquakes are down between 1 and 2 miles depths. That's 2 to 3 kilometers. So this scale here is in kilometers. 2 to 3 kilometers is this range right in here. So more or less in here is what we're looking at. Right. So this is above this South Caldera magma reservoir, which is the largest one in Kilauea. Around the same, a little bit below the Hale Magma reservoir, which is the one underneath the main pit. This might be a different shape than it was prior to 2018 when this map was made. And those are the two main magma chambers. They're also noting Kanakakoi over here to the side, and the trend that goes to Hale Magma as well. So 2 to 3 kilometers down, there's the range right there. So kind of between these two magma chamber depths, more or less. And at about the depth of this seismic Southwest Rift, which is shown here as being a separate branch off the reservoir system, than a volcanic southwest rift. So Kilauea's got this weird dual southwest rift thing going on. It's got the shallower one, which is the volcanic one, and a deeper one, which is a seismic one, right? And this is hard to just see in cross-section by itself. So there is an inset over here on the right, which shows what this looks like in map view. So in map view, there's Mauna right in there. The caldera would look something like this, right in here. The South Caldera is down here. Kīlauea crater would be right in there. So the volcanic southwest rift goes from Mauna from main caldera off to the southwest to the shallower region. And the seismic southwest rift comes in deeper, a little bit further to the south of the main caldera right through here, right? So that's the interesting thing to note right there. So I actually have taken this, and we're going to do another little excursion here. We'll look at this image, which is something I put together in Google Earth. I'll show you it here in a minute, but superimposing those rifts, those rift zones, volcanic southwest and seismic southwest here on our current earthquakes, and showing where the earthquakes actually plot. You see they're actually plotting in the seismic southwest rift area, more so in here, near the South Caldera chamber, but remember above the South Caldera chamber. So this is kind of in between the depth of both. Here's South Caldera, here's Halemaumau, and in between those two depths, here's the stuff occurring off to the south there. So it's really kind of wedged in between there. And that's why I wanted to explore a little bit further with you guys exactly what's going on there, and maybe dig out some interesting questions. So here's my Google Earth. There's our updated earthquakes. Unfortunately, the Google Earth scales the points to be really small. I can't make them any bigger than these little dots on your screen here, but that's showing you guys where the earthquake actually are. So if I zoom it out more, you can see a little better perhaps. So let's put on the seismic southwest rift for you guys. There it is right there. You can see the east rift zone only has one that goes off to the southeast, unlike, well, there's southeast there, unlike the seismic southwest there, volcanic southwest there, right? And okay, let me hide that again. And I want to highlight for you guys a couple of eruptions that have happened in the past. So these are all pre-2018. So you could argue whether these actually apply fully here to what we have going on now. But let's go start off back in September 1971. That's this flow right here. So that flow in September 71 created a fissure that was linked to Halemaumau crater right in here. The fissure actually goes something like this, right? I'm kind of connecting the parts that are missing, but that's the line, the trace of the fissure off that direction. And that erupted down on a southwest rift zone at several places coming out there, right? And if I come back and put our cross section on here, you can see, yeah, that is the volcanic southwest rift that connects to Halemaumau. That holds that pattern right there, right? Okay, let's turn off 71. Let's put on for you guys, put this back out. Let's put on 74. This is 1974, December. So zooming in a little bit more, there is the edge of our great caldera right in there, that crack. It's getting pretty close to that edge. So you could potentially invoke some complexity that connects this to the edge of the caldera here, and there's big fault lines that exist through here. So it might be that, but it is technically outside of the caldera there. So it's officially off in the southwest rift area. However, this one, if I pull up that overlay once again, that one actually falls over the seismic southwest rift. So there is this gray zone in here where near the summit, even a seismic southwest rift can erupt, right? So these earthquakes are not too far from this area. There could be an eruption that comes out from the ground here based on what's happened in the 70s at least, right? The counterpoint to that is, of course, that since 2018, everything is different. And since 2018, we have seen earthquakes light up this area, and it still erupts at Halemaumau every single time since 2018. So that's the context we're in since 2018. For it to do something like this, I'd have to see something new to believe it was going to happen. But the context is here just to show you guys the full picture. Back to 1974, there is that flow right there. There's one other one to point out. This is 1982 September. 1982 September broke out within that caldera region, but close to the source of these earthquakes as well. So here is the edge of the, let me pull off this overlay once again. Here's the edge of the inner caldera, edge of the outer caldera, right through there. Right, there's some other cracks that come through here as well, like that one, which this flow ponded against right through there. So technically this occurred within the great caldera, outside the inner caldera, and it actually put a flow out, hit another cliff, and didn't actually escape the caldera at that point in time. But that's also a potential, right? Eruptions can happen from this area that's within the great caldera, but outside the main caldera right through here, right? So that's one possibility of where it could erupt. I do have a few questions requested in advance I should share, that I'll share with you guys as we go along here. One of them is from our Two Pineapples Ohana. And one of them that I wanted to highlight right here is the question of, could an eruption potentially come out through the downdrop block area? Now, this is a little bit different. The downdrop block area is this chunk right in here since 2018, right? But we're talking about the possibilities of lava coming out. If it could potentially come out down over here, outside the main caldera and outside of this connector, or it could come out in here, then it's certainly possible it can come up through the downdrop block area. Right? The question is still the same one. Is there an easier pathway than the one that's found coming out to fill every eruption since 2018 in the pit? Right? There have been 4 eruptions in the last 5 years now. And can it find a new path upwards outside of this inner area into that downdrop block area right through there? We know that lava likes to come up along the edges of the craters. So that's why we've seen along the edge of the inner crater various fissures popping up. And we saw them all get buried. And as they get buried, the fissures don't open up underneath there as easily, it seems like, although we have had eruptions come up through the crust a couple times still. At some point, there'll be some fissure that comes out through this cliff over here, more than likely. Whether that's anytime soon, who knows, right? There's so much area to fill and to pressurize and adjust that we really have no way to predict what's going to happen there. But is it possible? Absolutely. So there is a first question to throw out there. That it certainly is possible, but if I were to bet on it, I'd probably bet in the same place it's happened the last 4 times, because that's pretty good odds. So once again, the overlay right through there, a little bit in between, just to kind of put all this in context for you guys. So a little bit of Google Earth for you guys here. And that said, I will go back to our other earthquake images and go back in time now to compare what the USGS pointed out to us as far as 2020 and 2021. So starting with 2021, this is activity near Kilauea Summit from August 24th to 28th, 2021. And this was plotted on a map. Here it is, and colored for 2 different populations of earthquakes. You can see the blue ones and the red ones right there. Like one that was a little bit more within that Great Caldera area, and one that was a little bit further to the south right through there. What they've done is actually project to the side what it would look like to slice a cross section through this edge of the model, and down over here, slicing along that edge. What you can see is that from those angles, they're actually separate by depth, there and there. I find this a little bit clunky to look at in this view, so I, in the past, have actually composed this with this geometry right here. So what you guys can see here is that upper image, there is the blue and the red, and from one side, there is the blue a little bit further north and shallower, and the red a little bit further south and deeper. And from the other angle, same pattern, a little shallower, a little deeper. And so notice how in these cases, these were actually what we would call a sill, a crack that's more horizontal, more like it seems like. And it's inflating with magma, and it's swelling and pressurizing and caused a huge amount of earthquakes. Eventually pressurized back to Hale Mauna erupted there 1 month after this occurred. And so that's the 2021 events. I can show you guys the map, the earthquake map from 2021 looked like this. Now, I'm going to zoom it way in. You can note a lot happening. Pahala was a lot more active that month. The south flank of Kilauea, a lot more active that month as well. Right, it was actually a lot less now. We'll see it again. Here is our southwest rift extension with our big bulge at Hale Mauna as well. So there is that signal that compares to today. But one big difference, you noticed back in 2021, we were still getting activity all the way down this upper East Rift Zone connector, all the way to Mauna Ulu. And in fact, here's Pu'o'o right in there. All the way to Pu'o'o, you see activity in the rift zone as the whole system was pressurizing not only the summit, not only the southwest rift, but it also had actually gone through and pressurized the upper East Rift Zone as well. It was still blocked over here, nothing going on all the way through here. Right? All this is, there's a whole bunch of nothing. But it actually had made a connection all the way to there during this era, right, back in 2021. So let's take you back further to the 2020 earthquake map. So here is the earthquake map from November 2020. And very similar pattern. Active Pahala, active south flank. There is a southwest rift zone and summit cluster. And once again, back in 2020, we still had quite a lot of action in this upper East Rift Zone connector. At that point in time, it was more to Mauna Ulu and less so to Pu'o'o, but you still see very active all through there. Right? So if I take us to our map today, here's our 1 month map of earthquakes today. And there it is. You'll note, yeah, Pahala is still active. Maybe slightly different pattern, maybe two clusters now as opposed to one big cloud. The south flank is still active here. Maybe less so than we saw in previous years, but still moving clearly. We still have our southwest rift extension. We have our summit blob, and we actually are missing all of our east rift stuff, right? So interestingly enough, one of the things that this analysis pulls out is how the upper east rift connector is actually extra blocked today than it was a couple of years ago and 3 years ago when the last time this happened, right? So that should be extra reassuring for people living down in the east rift zone here. And it just goes to show that it's a slightly different dynamic. Things can change between one eruption and the next, and the pressurization threshold to actually cause it to crack might be different. And just to put things in context there, so you can see some clear similarities and some clear differences as well with events happening now and the ones back 2020, 2021. Keep in mind, of course, that it took those an extra month to actually erupt, as was the case here as well in the most recent eruptions that we saw in the earthquakes coming up. So I thought I'd show you guys a few last things with the earthquakes here, a couple cross sections to pull in this last week of data here. So looking from we're going to do a cross section kind of along the strike of it, along the trend of it here to start, and then we'll come across later on and do any other direction, right? But so we'll start off southwest as A, northeast as B. That's a couple of slides from now. First, we'll look at the counts for this whole area, which is the same. And here it is for the last 2 weeks. So this is how many earthquakes over time, right? In that box that I drew, not just all over the whole map, unlike the other plots I showed you guys. So it's showing they're increasing. Here's a swarm increases really fast. They're increasing, a pretty big swarm increasing pretty fast there. Then it pauses for those 4 days here at the end of last week. And here comes in one swarm. And it stops, and here comes another swarm. And it stops, here comes another swarm, and another swarm. So you can see how it's really changed. It's not going at a steady rate. It's kind of ramping up and slowing down, and ramping up and slowing down, and ramping up and slowing down, which is typical. And so that's what we're waiting to see, how that continues to evolve, whether it keeps going, whether it leads to offsets in the tilt, and potentially more surface deformation than we're seeing at present, which is already a lot, but it could get even greater than what we see. So that's the counts. Here is depth versus time, right? And if you are expecting an eruption, what you normally see is a trail that goes all the way up to the surface of vertical lines. It goes all the way up. So these are showing a depth of ranges here, but the depth of ranges does not reach the surface. Right? It reaches maybe sea level or so. There are some surface events, but not clearly connected, right? If you're filling magma in an area down through here, it might be pushing the ground above it with the pressure, and that could cause little adjustments. So these little ones are probably just that kind of thing. Whereas a bigger cluster is likely affected by the actual magma injecting in areas like that, right? So similar range of depths all across the last 2 weeks. And you see there is that first batch, the first pulse, and that second pulse A and second pulse B coming through here with a gap in between here for that period of time right through there, right? So, okay, the reason I like these plots is more for the cross sections. So here they are. Here is A, the southwest, and B, the northeast. So looking at it on edge, how does it actually look? There is our surface. You can see here is the earthquakes likely adjusting above this on the surface. So most likely our magma body is filling an area that's more or less like this, right? Something like that shape. And if I take you back to the original map here, right, that's the triangle, like it goes across that way and it comes up shallower this way towards the surface right through there. And that's what we're just looking at right here in that cross section. Okay, so see, pretty spread out. You know, towards the southwest, where the earthquakes are more recent, these orange ones, it's actually going deeper over there, right? It kind of comes shallower from both sides there, but it's only the real center of that cluster that's getting the shallowest values, and otherwise you see the depths going off to the side there. Okay, the other angle, A to the northwest and B to the southeast. What does that slice look like? Here's northwest with A, and here's southeast. It's a little bit more tightly packed in here. A little bit more of a cloud of adjustment, maybe at the side there, and a cloud of adjustment above it here. So it does seem like it is squeezing in every direction there. It's hard to really compare there, but that just gives you a little bit of a visualization of it. And I did not have time to make this like a 3D thing like the other one, but there is the best I could do to show you guys what that distribution looks like underground. So that is all of our earthquakes. I've talked about earthquakes for long enough. I'll wrap it up here on Kilauea by talking about the volcanic hazards. So let's pull those up for you guys here next. Where are you, my hazards? We're going to use the VOG Measurement and Projection Project from University of Hawaii in Manoa. And the map today, the forecast looks, where is my loop? 1 second. Let's get this to actually appear here. Okay, there it goes. There is the VOG loop. Actually, loop it, zoom in a little bit. So only 86 tons per day is our input value for the model for how much gas is coming out of Kilauea right through here. So not a whole lot of gas to even disperse, but it does disperse to the southwest. There is one patch of orange pops up over here around Kapapala Ranch area, west of Volcano. And so certainly there could be localized effects downwind of the summit, even with these low levels. But overall, pretty good for VOG today. And that's expected until it erupts again. We should have good weather, good breathable air until that occurs. And then once it does, we won't for a few days, and we'll see a lot more color on this forecast plot right here. So that is the animation. And I'll show you guys here the Purple Air Citizen Science Monitoring Network. People have in their houses monitors that update to the internet. Here they are. You can see it's green across most of the island with our typical couple of outliers there that are not of volcanic origin. So still good clean air, as the forecast suggests there is what's being experienced on the island today. So that's the gas. It's good air quality out there. Not a whole lot of hazard compared to its worst possible situation. And now we'll move on to Mauna Loa. So let me put up our Mauna Loa here. We're not going to go into huge depth of Mauna Loa because we've been going for a while already. And as we know, there's not a whole lot of change on Mauna Loa, but it is worth touching base once in a while to remind everyone of what's going on and why that's the case. And so let's do that here today. For the last month of Mauna Loa, the summit has been inflating. There is that general trend with a little bit of a decrease there. This might be potentially some kind of weather effect, who knows? But the big picture is that it's been inflating, so it's still bulging, filling with magma underground. The difference is it's doing that without all these earthquakes. We have around a summit, earthquakes per day. Over the whole last month, our highest value was 7 earthquakes over 2 days there in the summit region. More recently, it's been 4 earthquakes per day. So it's filling with magma as expected, but not pressurizing to the point of actually cracking and quaking and all of that. So it's got a long way to go still, as expected. Here is a 1-year earthquake rates. So here's our rates now compared to what they were before the eruption. It doesn't even compare. For the last 5 years, still really low. the lowest point in the last 5 years of earthquakes still at this point today in Mauna Loa. The earthquakes that are interesting, as I pointed out at the top of the broadcast, are these deep ones colored by blues and purples that in the past have been associated with influx of magma into the supply system of Mauna Loa. So that seems to indicate that the feeder system is nice and healthy. And I forgot to turn that on. Nice and healthy. And if the volcano weren't already filling and swelling, then we might say, okay, something might change, but it's already doing that. So we just know that it's more business as usual. Magma is still coming in there to fill the shallow parts of the volcano. And it's being detected at a greater depth down there. So here's a cross-section, depth, and longitude. And here's where those things sit down here at 40 kilometers down, 30 miles down there, a long way below where the magma is coming out of the ground, where it can come out of the ground. And now depth versus time. Here's our purple band right through here. So here's the last week. A few events down in that range, similar to the few of the week before that, but nothing major, but still happening. And that's just a curiosity to note for us here. All right, so the 1 week tilt doesn't tell us much, but what I did want to show for you guys for the first time in a long time, hallelujah, our Mauna Loa GPS is updating to the web again. So here is our 1 year GPS distance between north and south of Mauna Loa caldera. Our eruption jumped it up, and as the lava came out, it kind of sagged apart. And since then, it's been refilling and swelling and swelling and swelling, and presumably swelling and swelling and swelling and swelling and swelling and swelling and swelling until to get to this point over here. Clearly, we're not going to catch any wiggles that happen in between. We have no idea what happened in there as far as that with this particular internet data set. I do believe that all this data was recorded by the USGS and it is available in their database, just not online. So I would expect if something major had changed here, we would have had some update. And since it hasn't, I'd expect any variations to be little wiggles, maybe, who knows exactly how it goes, but maybe it comes up higher and then flattens out more. In any case, we're still heading upwards in net distance across, and here we are at the far right end, still continuing the pattern that we saw post-eruption. So that's the summit distance across. Up and down, the summit is also lifting upwards. It's filling and swelling, as we noticed. And here it is, the most recent signals of upwards. Maybe something like that. Who knows exactly? But you can see the pattern, the general trend does project from there, right? Maybe a little faster, maybe a little slower. Who knows exactly how that went in there? Just put in some possibilities. But this will be good to track moving forward now to have that back online. So for the last 5 years, here's what it actually looks like. Build up the eruption over the last 5 years. Eruption, and then recovery to here. Right? So that's what that looks like over 5 years. And vertical, very similar pattern, down and back up like that. Now, the reason I wanted to show you all of this in this level of detail is because going back to this plot, which is a publication from Decker and al., 2008, this is distance across Mauna Loa summit. Seems we're just looking at, actually, this line, this direction right over here. And they're doing it using electronic distance measurement and ultimately GPS here at the end. But really, it's EDM we're looking at here for 2 eruptions of Mauna Loa. 1975 was back here, that red line. And you can see that distance. So let's look at this line here. It was changing, got a little faster, jumped up for the eruption. And here from 1975 all the way till, let's pull it right in there. Hard to tell exactly. Let's call it 1978-ish, right? So maybe 3 years or so. It was still spreading apart. Then it sagged a little bit, started spreading apart some more, until it actually erupted from the next time in 84. In 84, there is the offset, the eruption sagging. Then here it is, reinflating, upwards. In that case, let's see, the first flattening out is maybe here in 1987 or so. But it keeps going up really until 1990 before it really drops down in 1991 or so, right in there, right? So in that case, also many years of it actually stretching and expanding apart before we saw an eruption, right? Or saw stabilization, I'll call it. Because you can see here that by the post-84 era, by around 1995, 1993 or so, we're kind of flatlining and plateauing through here. And that's kind of the last stable period before magma reinjects in the early 2000s into Mauna Loa there, and things changed again a little bit. So pretty similar pattern is the bottom line, right? Coming up for a few years, and then back to what we just saw. It could be coming up. In this case, it's been less than a year. Could go on for a lot longer. And that's the update from Mauna Loa that we have for you guys today. So we only have a couple of final points here before we turn to some discussion and questions and that kind of thing. First is the USGS Volcano Watch. It's out, posted on Hawaii Tracker. And today's Volcano Watch is aloha to the University of Hawaii's newest geology professor. And it's awesome to hear that Dr. Liz Gallant from USGS HVO, which has been there for the last 2.5 years, is now making start of a new position as an assistant professor at University of Hawaii in Hilo. So congratulations to her. I won't read her whole bio here on camera, but this is available for you guys to go and check out on the website and our Facebook group and elsewhere as well. So Volcano Watch for this week. There it is. And beyond that, we have some community items to finish up with for you guys here. So first thing to remind you guys, in our community corner, this is way too small for even me to read, Kilauea eruption recovery, the August update to the roads with the EA being released, the draft EA, and it's open for public comment until September 5th, 2023. So go to Kilauea Recovery website and you can find how to do so. And you can also find the presentation that was delivered as well, and gives you the email address to submit this by September 5th. Right? So we're coming up on a day here. If you haven't done this and you have input on the EA for the roads, Kilauea roads recovery in Puna, then here is your reminder. Okay, and next on our agenda for community here is national park events. So actually this past week was scheduled to have Dr. Dalton Swanson speaking at Wikahuna. However, we did hear that the auditorium sprang a leak and had to be closed. This program is once again postponed. So we're still waiting on this one. It was postponed once before due to Tropical Storm Calvin. Second postponement, we'll have to see when it gets rescheduled off the books for now. This coming week, scheduled is Nani o Kahuku, One Woman Living History Play, Tuesday, August 29th. However, you'd imagine you have to probably fix the leak. So this, I would say, is still pending more information there, but it does discuss, this is a reenactment of from the diary of Hannah, or Nani Pi'ilani Jones, portrayed by actress Elia Joy Kanehaulua, who were living in Kahuku Ranch from 1871 to 1887. This is just after the eruption of 1868 in Kahuku from the southwest rift of Mauna Loa there. So they were probably dealing with some volcanic after effects. That would be pretty cool to see, and we'll see if that actually happens or not. And if it does, we will see what we can do to bring it to you guys by live stream as well. So that's all there is on the books for August here, and we'll update you guys on September next week. That's the national park. One last thing on that Kahuku area. In case you've never really seen Kahuku, we haven't talked about it a whole lot in our updates here and there, but there is this whole 1868 eruption of Mauna Loa. Some of the houses people used to live in at the time there, so you can see what it might have been like for Nani to live in this area right there. Earthquake damage in that image there. Here's what the areas actually look like if you hike around at Kahuku United National Park. You can see fissures and lava trees and revegetation and big lava flows down in there. And the picture I really want to show you guys was this one. Right? So we're looking in an oblique view. South Point is off in that direction. The south tip of the island is way over there. So Kilauea is actually up here in that area over there. Mauna Loa Summit is up that way. And what we're looking at is this is a big fault line that allows this part of the island to essentially sink relative to this side of the island there. So it's associated with the south rift of Mauna Loa and the construction of the island and all of that. And leaving it at that, this big black flow right through here, along the base of that cliff right there, and the one over here, and the one over here, all these that feed back into this area, that's the 1868 flow. that made it to the ocean in only a few hours. And up in the area up through here, this is where you can visit the Kahuku unit of the national park, and where people were living to give those reenactments and accounts that are now basis of reenactments. So pretty interesting view there of big eruption of southwest Mauna Loa, one of the lowest eruptions on that rift zone that's been documented in human times here. All right, so a couple final things here in our community corner. One is a reminder that the Big Island Press Club, in collaboration with us, has an internship open. You have to be a Hilo student. This is something for students pursuing higher education in journalism or related field, or engaged in any kind of journalism at the collegiate level. Right, so there's all kinds of things through here, but essentially you can help us with our content, putting it on all the different platforms, and whatever the intern desires to focus on, we can accommodate that to some degree as well. So if you know anyone at Hilo interested in journalism, interested in social media, send them this information about the Big Island Press Club internship for a Hawaii tracker. It does have a stipend and credit hours as well available. Last thing to mention here is our survey. So I mentioned this a while ago, like an hour ago now. If you haven't had a chance to fill it out and you are able and willing to do so, maybe we can drop another link and remind you guys. And here is one last reminder for you guys that we would really, really appreciate it. Every single one, like we're not expecting to get many results. So I think that anyone is willing to click through to go to Google form and fill it out for us, we really appreciate it. It's all multiple choice, should be pretty fast, we hope. The questions come in pairs, like each pair of questions is really similar, so it shouldn't take a whole lot of thought, I don't think. I hope it's quick for you guys, not a big burden. And it'll be really, really useful to us. So if you can, please fill out our 2023 education survey, volcano education survey. So Dane, I have talked myself out of slides here, and we're ready to say some thank yous. And
let's do that real quick. We're running a little long, but that's fine. Did have some donations come through. Want to shout them out. Start out. First one was Skagit Ed, came through, recurring donation there. Appreciate it. Interesting survey, Hawaii Pod. A bit strange to answer a few questions being on the mainland. Thanks. Hal came through with a $49.99 super chat. Says, mahalo nui loa for all you do. I was up all night watching you when Mauna Loa was erupting. Got nothing from anyone else. Filled out the survey. Appreciate it there, Hal. Earthquake Sim comes through with $20. Says, thank you for all these educational videos. Your work and dedication have always been inspiring to me. Can't wait to visit the Big Island again. Appreciate it there. And then Tim Hazeltine comes through with a $100 super chat, and I believe there was no comment with that one, but thank you, Tim. Appreciate it there.
Yeah, mahalo, Tim. Mahalo, Earthquake Sim. Mahalo, Hal. And mahalo, Ed, as well. Appreciate all you guys.
Yep, we did have a couple
questions in there. Okay, yeah.
No, there's a couple questions here. Not going to do too many, but Carl asked, does the inflation-deflation cycles weaken the upper crust?
This inflation-deflation cycle is weakening the upper crust. That's a good question. I suppose yes, but the upper crust is already pretty weak to start with, right? Especially after 2018, we saw the massive collapse, all the earthquakes in there. There's tons of cracks that already exist. So when inflation is happening and deflation is happening, they're kind of using cracks that are already there to accommodate the movement. And so it maybe is not breaking them so much, but like every time you wiggle a crack, it's like, imagine like having a loose tooth, right? It can kind of wiggle, but if you keep wiggling it over and over and over, you might eventually wiggle it all the way out. So might be some of that happening. And that's where I base my answer of maybe it's weakening that way. But it's doing so just a little bit, considering it's all pretty weak already because it's all cracked up already. That's my perspective on that. It might depend exactly on the geometry of it, but that's basically it there.
All right. Next one is from JW. Ask, and this one's kind of detailed, but in injection molding, the feedstock pellet grind through the extruder causes the plastic to melt and push out the gases, the air. Is all that grinding earthquake energy doing the same to the magma?
It's not exactly the same. That's a really interesting process there that you mentioned, JW, about the injection molding. Yeah, I wasn't aware of that detail. That makes a lot of sense. What happens with the volcanoes is the gas is actually dissolved in the magma, right? And so there's another question that kind of is similar to this that Lou and Two Pineapples gave us, and the question for that one was, is it a pressure from the gas, or is it large earthquakes that push the magma through when an eruption occurs, right? So kind of similar. I'll touch on both here. So it's because the magma is at a certain great depth, and that depth is usually more than a half mile or a kilometer down. That depth is sufficient pressure for the gas bubbles to stay dissolved inside of the magma. So the magma's got bubbles in it, but not very many and not very big ones. It's kind of like having a bottle of soda, like a bottle of Coke, and it's still got a top all the way screwed on. It's still sealed, hasn't been cracked yet. And you can move that bottle around. You can see bubbles can be in there, but they kind of not many. It might just be a few here and there. But if you unsnap the top and release the pressure off the top, in the case of a volcano, that will be a crack actually opening to the surface. Then the pressure suddenly drops there, and all that magma starts to rise. And as it rises, it allows bubbles to nucleate within the magma. Once a bubble actually forms in the magma, it starts to expand. As it expands, it rises. As it rises, it expands, and it can't stop until it pops out of the ground somewhere. Right? It's going to work its way up and out somehow or another, potentially actually breaking the ground. The gas can actually break the ground on the way out, as we saw in the last eruption, where we saw a huge surge of lava, very frothy, and the ground actually bulging upwards. But it can also be the magma itself pushing its way up if the gas can escape without causing the surface to break, if that makes sense, right? So we in the past have had craters, for example, with lava lakes, and the lava lake maybe wasn't completely closed off, and so you might have the gas coming up first and separately, and then the magma coming up and pushing and causing some activity as a consequence of that, right? So it's more the pressure changing and the magma nucleating bubbles that causes the gas to escape, and then it coming up and outwards, right? So that's as far as injection molding, I think they're probably, if I thought about it somewhere, I probably can pull out some analogy of how that actually fits in here, but it's not exactly the same as far as the gases is what I can say there, right? And as far as the question from Two Pineapples, is it pressure from gas or earthquakes that push the magma through? It's the gas, really, but the earthquakes have to open the pathway for the gas to escape. So it's both, actually, right? It's the earthquake first, and then the gas. But the problem is you don't know which earthquake it's going to be. So you don't know if it's going to be the big one or a little one or another little one. So you keep watching earthquakes. We've had hundreds and hundreds and hundreds. Can't tell which one is going to be the one that actually breaks it. So when you see gas come out, that's bringing a lava, right? But it's usually at that point not a prediction anymore. It's an observation, like, okay, there it is, because it's happening. Bam, bam, bam. You see the gas, you see the lava within a few seconds of each other. So that's a discussion
Awesome.
I can suggest there for that one. I appreciate that,
Right.
JW.
All right. Yeah, we've been going for about coming up on an hour and a half now. The plan is if nothing happens on Kilauea, we will be back at our normal time, 5 p.m. Hawaii Standard Time next Thursday. But if something does, it erupts, we'd expect to go live. We'd expect Two Pineapples to be on scene as well. Definitely check them out. We appreciate their support. They've been behind the scenes helping us out on this one, so definitely appreciate Two Pineapples, and they will be going live and doing one of those long haul streams the night or the morning or whenever this thing finally happens. So yep, check them out, and we'll be intermingling with them and working with them, trying to give you guys the explanations of what's going on, but also some great footage of what's going on from some different angles and things like that. So we appreciate them, and it's something. Yep, that's if something happens. Yep.
I did notice there's one more question that I maybe didn't answer explicitly. I showed this plot before, but there's one more question from our Two Pineapples Ohana, which is, how many kilometers under the surface is the magma? Right. So here maybe it gives you an idea. At Halemaumau, it's right at the surface. The chamber itself might be 1 to 2 kilometers down. South Caldera chamber is deeper down, 3 to 5. The rift zones themselves, you're looking at in a range of 1 to 2 usually kilometers down, like kind of that far below the surface. It gets lower over here, so it's probably 1 to 2 kilometers, maybe 1 to 3-ish, call it something like that. Right, so that's how far down the magma actually is, to answer that question as well. So I think that's it for questions.
Yep. And I was just signing off there, going to say sign off. So, yeah, that'll do it for me.
I appreciate it, Dane. Thanks for your help today. Thanks for leading the discussion on chat and answering all those other questions in there. And appreciate all of our community coming and supporting us. Thanks if you fill out the survey. We really appreciate that. If you want to do that after we're done streaming here as well, then please, by all means. The link is also posted on Hawaii Tracker Facebook group in case you need to find it.
Not
after
quite yet.
We're off. Not
it
quite
will
yet.
be. No, after
It
the
will
stream
be
ends.
imminently. Awesome. Thanks, Dane. And yeah, as he said, we'll see you guys next week unless we see you sooner. So from Hawaii Tracker, H. Very, he's Dane DuPont. I'm geologist Philip Ong. Aloha, everybody.